Good afternoon to you all. Myself Vinayaka. I am conducting the webinar for Midas Civil Software on the topic of composite structures. Fine. Now, this is a software screen. As we have discussed earlier in our training session, so I will not explain the menu systems over there. So I will directly go to the modeling option, File, New Project. So the new screen is opened. I kept my system, my unit system as in kilonewton meter. And the first step, I'll be creating the properties, material properties, add. This is the material database screen. I'm creating the material. The type of material is concrete. And the standard is EN04RC. Grade of concrete M3545. The same name will appear in the name of the material. I'm just clicking apply. This is for the main girder. I'll be creating one more material property, that is a C3037. C3037. This is for the cross girders. And click OK. So we have a two material property, and then create the section property. Click add button. This is the cross section database. So as this cross section is a composite structure, so I am creating the section from the composite database. Section type is composite I section, where I am going to create the two section properties. That is, one is near the support and another one is near the midsection, and in between I am going to create the taper section, which is tapering from T to I and I to T. So before that, I am saving this model. I saved the model. Fine. Now my first section is support section. Okay. I am just selecting the cross section as a composite type. Name I am giving as a support section. Section type is composite I. This is the reference picture. And this is the information about the slab and the distance between the slab and girder and the slab thickness. Fine. And then it is a 3 meter, and TC is a 0.2 thickness, and the HH is the distance between the girder and slab. I kept it 0. And girder dimension is symmetric. And this is the reference picture for giving the dimensions. It's a HL1. That is, you can see here, HL1 is the top flange thickness of the girder. So it is a 0.3, and HL2 is your taper section, it's a 0.2. And then HL3 is 0.8, and HL4 is again 0.2, and HL5 is 0.3. So now you can check it is a total of 1.8 meter depth, and then BL1 is a web thickness, I'm just keeping it up 0.45, and BL2 0.55, BL4 it's 0.451, okay, for BL2 I will just keep it up 0.6 to make the clear cross section over there, and this is the symmetric section, and then BL2 0.6, BL4 is 0.451, and this is the material for the girder and slab. This is the slab material ENRC. See 30-37, and then for the girder it is 35-45, is calculating the modulus of velocity ratio for the composite section, and the offset command we are keeping the center top offset, and the show calculation result. The program is calculated the composite property before composite and after composite. It means before composite this is the property only for the girder, after value after is the property after composite, that is a girder and slab. This is my support section. Apply. It's added in my section data, first one, and then second I am keeping the name as midsection. Here I am changing only the BL1 value. I'm keeping the value is 0.15. Now we can see the cross section is modified according to the dimension, and the remaining parameters are same. Again the program is calculating the composite property, that's a before composite and after composite, and then click apply. The second property is added, and then tapered section, this I am using from the tapered tab, and the cross section type is same type we have to select. It is a composite PSCI. Here I am giving the name as a taper left. Number of girder 4. Center to center distance is 3 meter. BC 3 meter. Thickness of the slab is 0.2. HH is 0. It is symmetric girder. Instead of typing the properties again, I am importing the property tapering from support section to mid. Tapering from support section, size I is the starting point of the member, and J10 is the end point of the member. J10 will be a midsection. Fine, and then this is the property of the girder and slab. girder and slab. One minute. I'm sorry, the system is it is not going over there. So let me try again. It is hanged over there. Just a minute, I will just reopen the model. So whenever we are creating the taper section, we can give the number of girders, the total composite member properties. After that, we can create the composite section, the taper section, from the existing properties. So that's why we are importing the property from I10 and J10. So I'm creating the taper section again. This is the composite PSCI. I'm giving the name as taper left, and number of girder is 4. Center distance is 3 meter. BC is 3 meter. Thickness of the slab is 0.2, and height of the height between the girder and slab is kept as 0. And then import the property from I10, its support section, and J10, it's a midsection. Now you can see the two properties. And then this property of the girder and slab, I am selecting 30-37 for slab and 35-45 for girder. And we have the 3 types of tapering, that is the linear, parabolic and cubic. For this condition, I will be using the linear tapering for y direction and z direction. And offset is center top offset. And then so calculation result, this is showing the property of before composite and after composite, as well as for the I10 and J10. So it is calculating the property for I10, J10 separately, and then it's before composite and after composite. This is the taper left, I just created again. Taper left is done. Now the taper right, that's the 4th section. I'm giving the name as taper right. Again, I10 is midsection and J10 is support section. Import, add. So this is my 4th property, that is a taper right. And another cross section which I am going to create for the diaphragm section. So I am giving the name as diaphragm, and the user defined. The height is 1.5. So we'll keep it 1.6, and B is 0.3, and again giving the offset to center top, but I have to direct the slab thickness because the cross diaphragm should be placed below the slab. So the vertical offset as a user defined, I'm directing minus 0.2 is the slab thickness, so I provided minus 0.2, and the user reference is from the extreme fiber. Click OK. Now you can see the red dot is your element location, and this is your cross section which is placed below the slab. Click OK. So totally we have 5 cross sections. Now this is the work tree. So as we know already, what is the color pattern which we are following here? If the text is in black color in your work tree, it means you have created the command which is connected with the model. That's a completed process. And if the text is in blue color, it means we have defined but not associated with the model. If it is in red color, we have not defined and not associated with the model. That's the 3 color patterns in the work tree. Now we will create the geometry. Go to node and element. Create the node. The first node creating at the origin point. Copying 3 times. Y direction 3 meter. Apply. So now we have totally 4 numbers, 4 nodes. You can see the node number over there, 1, 2, 3, 4, first node at the origin point. Fine. Next, we can create the node and then connect. That's the usual procedure. Otherwise, you can use the extrude command. As we seen in the on-site training, we used the extrude command directly. So now we will use the same extrude command. So this is the node to line element extrusion, and you know we have the other extrusion type also. That is a line to planar and planar to solid. Now we have only the nodes. So I am using node to line element extrusion. Element type is beam. This is the material, and the cross section is support section, and your distance is is 0.3 meter one time. Otherwise I can use unequal distance also because all the dimensions is in x direction only. So it's a 0.3, 2.7. Select all the nodes and apply. Now you can see the cross section is created. I have provided the first 0.3 meter because of providing the support offset. You cannot provide the support node exactly at the tip of the edge. So I provide the 0.3 meter is the offset to place the support condition. And then second is copy from node number 9, 10, 11 and 12. This is my taper section, that is again it's a 3 meter. Change the cross section, that is a tapered left is created. Again select the node number 13 to 16 and then change your cross section to mid section, and distance is 5,5, that is 5 meters. Center point is exactly at the midpoint. Now you can see it is totally 10 meters of the midsection. Again select the node number 21 to 24 Now the cross section is taper right section. It's again 3 meter. Again 25 to 28. This is your 2.7, 0.3 meters. Sorry. This will be the last cross section. This one is my support section. I just drag and drop if you want to modify. Okay, yeah. Now you can see the thing is this is the support section, which is highlighting in the window in the model, and this is the mid section. This is a taper left, and this is the taper right section. So we have justified whether we have assigned the properties correct. Fine. Now the cross diaphragms. Now either I can use extrude command or I can use create element also. Now I will show the create element. So select the material property, and section property is a diaphragm section. Node connectivity, I can directly click on the nodes, middle also. So I created the diaphragms. Now the model is done. Now we have to provide the support condition. So that is exactly this location. I am copying the node, translating to downstairs. Node, translate, copy. The distance is minus 1.8 meter. Sorry, I'm sorry, I'm just giving the distance of minus 2 meter is the correct one, including the slab thickness. Minus 2 meter is the correct one. Now it's copied now. Now we will provide the support condition. Go to boundary, define support. It's a pin support, that is a translation. X, Y, Z directions are fixed on the left side and the rotations are free. And the right side, X is released, so we will achieve the zero bending moment near the support. That's a simply supported condition. Now you can see the support conditions over there. This is the support condition which we provided. It is displaying in the color pattern. I will just show it by direction, support by direction. This is the supports. And then we have to make the connectivity from structure to the support. Again go to boundary, elastic link, rigid type, and two nodes. Click on the nodes. It will display your link property. I'm just making the display of the link. Now you can see it's in the yellow color. Again on the right side, I'm creating again It is created now. So this is the structure and the support condition and the link connectivity. Now next is we have to create the one more material property that is called a time dependent material property. For that I am changing the unit to Newton millimeter. Go to properties, time dependent material property for a creep and shrinkage. Add. We will following the European standard. This creep and shrinkage, the C and S, and compressive strength value. It is 30. First one is a 45 for main girder, 45. Notate size of member, it is 1000 millimeter. A type of cement class N, and type of code EN 1992, 2 concrete bridges. And show result, this is the creep coefficient, and this is our shrinkage strain for that. Now the display is updating from your side. It will delay to update the screen. I will wait for that. Now you can see this is your shrinkage strain and creep coefficient. Which is we are using for the creep and shrinkage calculation at the type of construction stage analysis. Generally, these properties are important to analyze the structure with a defined age of concrete and the corresponding strength for the analysis and to calculate the stiffness properties. So that's why we are defining these properties, creep and shrinkage and compressive strength parameters, and then we are connecting this information with the construction stages. Fine, this is the creep coefficient and shrinkage strain, and click apply. Again C and S for this is for the diaphragm. Again characteristic compressive cylinder strength of the concrete is 35 and show result and then click OK. So two time dependent material property we have defined it. One is for the main girder, second is for the diaphragm section. Done. Next is we will define the compressive strength values. Compressive strength, add, compressive strength for main girder, select the standard, the code, European standard. It is for the 45 and cement type is N.25. Redraw graph, it is showing the compressive strength graph for the main girder. Again another property for the diaphragm section. Select the code, select the edge of concrete, the compressive strength value, redraw graph, and then click OK. So two defined properties are made for the compressive strength values. And then the time dependent material link. Select the compressive strength parameter and compressive strength function what we define and connect with the material property, select and add. Similarly for the diaphragm section, select the material property for creep and shrinkage and compressive strength, connect with the material and add. Good afternoon. This is Vinayaga Murthy from Midas IT. I will be conducting the webinar on the composite bridge. So I will directly open the software screen. This is the software screen. And I will be opening the new screen, file, new project. And this is the unit I am keeping at kilonewton meter. And then the new file I am saving as, giving the name, composite bridge. And then first I will be defining the property for the material and cross section and time dependent material also. Properties, material, add. This is the material database. Select the type of design is concrete. Select the standard, ENRC. So that's a 3037 for my slab and diaphragm. Apply. And the second property is your 3545. That is for the girder. And next property is for the steel, that is for the prestressed cable. Is for the tendon property. I defined the three material property. Section property, add. This is a database for the section. As this is the composite bridge, so I'm directly accessing the section property from the composite tab. Composite, select the type is composite I section. So giving the name as support section. BC is 3 meter. Thickness of the slab is 0.2. Girder is symmetry. And this dimension is based on this reference picture. And HL2 is 0.3, HL3 is 0.2, it is 0.8, and HL5, HL4, sorry, HL1 is a 0.3, HL2 is 0.2, HL3 is 0.8, HL4 is 0.2, HL5 is 0.3. And then BL1, it is 0.45 and BL2 is your 0.65 and BL4 is 0.451. And the material property for girder and slab, for slab we are selecting the 3037 and girder is a 3545. Click OK and offset is center top offset, and then click apply. This is the support section is created, and next section is midsection. For midsection, the only difference is BL1, it is 0.15. Now you can see the cross section is changed according to this. Apply, so midsection is added, and then tapered section. So this is your composite PSI type. So I'm giving the name as tapered left, and number of girder is 4. Slab center to center distance between the girder is 3 meter, BC is 3 meter, TC is 0.2, and girder is symmetric. Yeah. Now we can import the property for I10 and J10, that means 2 endpoint to make a tapering. So tapered left is starting from support section to midsection tapering, J midsection, and then material for slab and girder. For slab is 30-37, and for girder is 35-45, and the tapering is a linear tapering and Y and Z direction. Again, offset is center top. Apply. So taper left is added, and then taper right side. Taper right side, ith end is from midsection, end section is support section. And it's added the taper right, and then the diaphragm section I'm selecting from database, solid rectangle. I'm giving the name as diaphragm, and then the size is it's 1.8 meter by 0.3, and offset is center top offset, but we have to define the diaphragm section below the slab, so I'm deducting the slab thickness, that is 0.2 meter, from the extreme fiber reference. Click OK, and then fine, done. So totally we have 5 sections. In the work, it's displaying 3 material and the 5 cross sections. Now we can generate the geometry. Let's go to the node and element. So, node and element, create the node. First node at the origin point, copying 3 times. In Y direction 3 meter. Apply. So totally we can see the 4 nodes as is displaying in the screen. We will use the extrude command. Select the material property, that is the girder. Section is support section in equal distance. Select these nodes, copying the distance of 0.3, 2.7. Add, and then select node number 9 to 12. This is your 3 meter. This is your tapered left cross section. Apply. Again select the node 13 to 16. This is your midsection. The distance is 5, 5. And the node number 21 to 24. This is your taper right section, which is the 3 meter. Again, the node number 25 to 28. This is your support section. Distance is 2.7, 0.3. Now, this is a symmetric section, will be supported. This 0.3 on both sides I provided to give the support. That's an offset of 0.3 meters from the edges. Now we have to create the element for the cross diaphragm. So select the material, slab and diaphragm, and the cross section is diaphragm section, and connect is connected, and the middle side and the edge side. So it's made accordingly, and then I have to copy the node to provide the support. So I have selected both the sides. Now copying the nodes, node and element, translate, copy is -2 meter is copied at the bottom. Now you can see the node is copied at the bottom. Now the left side support, select the support condition, go to boundary, define support, D all, or I mean all the translations are fixed and rotations are free. Click apply. The same way on the right side, I release the X direction, apply. Now the support condition is defined. Now you can see the support conditions over there. It's like this. Now we have to make the connectivity between the structure and the support. Now again go to the boundary, elastic link, rigid type, connect by the nodes, 2 nodes. So it is created. I will just display that also. It is displaying in the screen. Now we have to define the material property, I mean time dependent material property. For that I am changing the unit to Newton millimeter. Newton millimeter. Go to properties, creep and shrinkage. We have to define the property for that. There is for the girder, select European standard. It is 45 Nm squared. It's a compressive strength. Humidity is 70%. Notional size of member is 1000 millimeter. Type of cement class N, and standard is EN 1992. 2 concrete bridges. So result, this is their creep coefficient and shrinkage strain value. And then click apply. Again second is the diaphragm and slab. Characteristic compressive strength is 35. Remaining parameters are same. And then click OK. Now the time dependent material property for creep and shrinkage we have done. Next we have to provide for compressive strength. Go to compressive strength, add. Now the name I have given as a girder. Select the European standard. Compressive strength is 45. Class N, cement type, redraw graph. This is the compressive strength value. Click OK, and then click one more property for the diaphragm. So European standard, 35, redraw graph, and click OK. And then the time dependent material property link, and select the creep and shrinkage what we defined for the girder and the corresponding compressive strength value. I can select the girder and add. Similarly for the diaphragm sections, select and add. So these properties we have done so far. And next is a load. Static loader, we have to define the static loaders, load cases. This is for the self weight all load cases, it's a dead load type, add, and cross barrier load, that is your dead load of component and attachments, add, pre-stress, it is your pre-stress load cases, add, and close. Now we will apply the load one by one. That first one is the self weight. Select the load cases, and load group we have not defined, but this we have to define. Before that, I will explain what is the purpose of this. So this groups, you can see here the structure group, boundary group, load group, and tendon group. These are the groups which we are creating for the construction stage analysis purpose. And according to your construction sequences, we are activating and deactivating these groups. For that, I will be creating the group, structure group, giving the name as main girder, add, and the diaphragm. And secondly, we have boundary group, right click, new, give the support group name is support, and second one is links. So two boundary group we created, and then load group, self weight, cross barrier, pre-stress, we have defined it. Now we have to select the member according to the construction sequences. And then select only the main girder. Select only the main girder and drag and drop the main girder group. These nodes and members are connected with this. Again, select only the diaphragm sections and drag and drop with this, and then supports. Go to work, right click on the support, go to table. This is the group by default. This we have to select as a support because this functional is assigned to be as a support. And then elastic link, go to table again. Again the group name changes the link. It assigned over there. Now we will create the load. We have defined the load cases and we have to apply the load case one by one. Go to self weight, select the load case and load group is self weight, Z is -1, add, and then close. And second is element beam load, that is for the cross barrier. Go to element beam load, select it's a cross barrier, load case and load type, eccentricity from the offset from the global direction, which is 1.5 meter from the reference element that I will select from this exterior girder is 1.5 meter, load is -2.5 kilonewton, sorry, it should be kilonewton meter, so I'm changing to kilonewton meter, and the distance will be 1.5 meter now. Okay, this is exterior girder and click apply. And similarly on this side, the eccentricity is negative, that is -1.5 with the same value of UDL. Now you can see the load which is applied at the edge of the girder. Fine. Now next load case is the prestressed load. For the prestressed load, we have three steps. First, you have to define the property and tendon profile, and then tendon prestress. Okay. So first, we will define a tendon property, and this is the tendon name I'm giving as a tendon. It's a tendon type is a pretension, post-tension, or external prestressing. Affecting external prestressing, the material is tendon, and total tendon area, we are giving the 19D13, that means 19 number of strands and 12.7 mm dia. This is total cable area for one cable. That diameter is 90 millimeter, and the relaxation coefficient as per the European standard for low relaxations. And the ultimate strength, yield strength, curvature friction, wobble friction, and anchorage tip 6 millimeter is considered by the property. So it's defined. Next is the tendon profile. Especially for the tendon profile generation, this is the input table. Either if we have the coordinate in Excel sheet, you can directly copy paste the Excel sheet, otherwise you can define the coordinates in this table itself. The first one is giving the name as a 1, the tendon property. Tendon assigned element is the girder element numbers. We have to select from where you want to create the cable. This is the first main girder I have selected, and it's a 3D type, input type is 3D, so that I can directly enter the X, Y, Z value. And we know the distance of the girder is 22 meter. And then to define this, I'll open the Excel sheet. This is the Excel sheet file. I will creating cable 1. This is my X, Y, Z coordinates. Now this I have to make it the total 22 meters. I have to make it for up to midpoint, that's 11 meter. Why I kept keeping a 0? Reference from top, I'll keeping as here's my cable number 1. Now you can see the values. This is my cable 1, 2, 3, 4. So 4 cables I have. Again, the X, Y coordinates are same for all the cables. Only the Z coordinate is varying. So we have defined the 4 cables. Let's see how I'm using this cable. Just copying the coordinates and pasting it in the table. Make symmetry. Starting point of the cable is my element number 1. Applied it. Now you can see the cable is applied over there. Let it display for that cable profile the first cable which is displaying over here. Let me see. X 22 meter. One minute. I will just check the thing is. What is my coordinates? From 11, make symmetry. Fine, the first cable coordinate is defined over there. Now this is the length of the cable. Let me remove the elastic link and rigid link. The tendon profile. I'll creating it again. Yeah, it's a tendon 1, that is a T1. I'm giving the name as a T1. Tendon property, tendon assigned element will be the first girder. This is the girder. It's a 3D coordinates, and copying coordinate from the Excel sheet and paste it over there. Make symmetry. The starting point of the cable is element number 1. Just applied it. It's created now. I will just display the thing is. This the first cable is created over there. and then I will add the second cable. Add the cable. Now this is my T2. Again select the same coordinates. Now this will be my cable number 2. Copy the coordinate, paste it, make symmetry, and apply, and then change the name is T3. Remove the existing coordinate, and then copy from Excel sheet. There is a third cable. Paste it. Copy and paste over here. Make symmetric and apply. Again T4, that is the fourth cable. Remove the existing coordinate. Copy the coordinate from your Excel sheet. And paste it over there. It's not copying again properly. Okay, copy the coordinates, paste it, make symmetric, and apply. Now we have a 4 tendon coordinates. I will just display the coordinates over there. Display the coordinates over here. And now we can copy the coordinates from first girder to other girder. That will be just select all the cables, copy, equal distance 0, 3, 0. Auto adjust with the tendon length. Click OK. Again copy. This time is 0, 6, 0. Again copy one more time. This is your 0, 9, 0. Auto adjust, copy. Now you can see it's easily copied for all the girders, the prestressed cables. Now you can see if you double click, it will display where the cable is associated with this one. So once you're copying it, automatically it identifies the second girder, third girder, and fourth girder. Fine. Now next step is tendon prestress. Select the load group name and load case name as a prestress. Select all the cables. Forced value is the both end jacking. It is a, if the unit is in ton, I can directly change the ton value. It is 290. This also 290 on both the sides. Grouting after one stage. There is a one construction stage. Add. So the prestress force is applied over there. So prestress force is applied. And then next, what is the case is the live load. Next, go to the live load condition. That's a moving load. Select the code, Eurocode, traffic lane, add lane 1, lane width, eccentricity. Suppose if you're giving eccentricity from the reference point, it makes the difference. If you're not giving the eccentricity, the lane will be creating on the line itself. Okay, eccentricity of the vertical loads. And this is the vehicle load distribution through the lane element or the crossbeam, as this is the grillage model. So the load distribution via crossbeams, that is the diaphragm sections. And create the lane. This is the first starting point and end point. And then click apply. it's created, and then change the name is lane 2, remove the existing coordinates, and then select the second girder lane specification, create again. So two lane is created. 1 minute, it is not done actually. So the two lanes are created. You can see in your work also, it is displaying the two lanes. So it is denoting in the green, and the lane name also it's displaying on the screen, lane 1 and lane 2. And then you have to select the vehicles. Select the vehicle. This is the vehicle database, add standard vehicle. So the load model 1 and then load model 3, suppose click 2 vehicles, and then it's defined but not the function is not completed. That's why the moving load analysis it's showing in blue color. Go to moving load cases. This is the moving load cases function. So add. So create the moving load combinations. So lane LM 1 and 3 multi. So this is the load model 1, load model 3. Select both the lanes. These are the selected lanes. And click OK. So first case is created. Now this function is in blue color now. It's converted now. Now the thing is, analysis is done. Sorry, the moving load analysis input is done. And then we have to create the construction stage analysis. As I told you earlier, construction stage, define construction stage, add, it's a stage 1, duration is 20 days, main girder we are activating at the first stage, with the age of concrete is 14 days, and then boundary conditions, support and links we are activating at the original activation position, and the load is sulfate is activated, and the pre-stress we are activating at the first day because the concrete age is 14 days, and then apply. Again in the stage 2, again duration is 20 days, element, the member wise, the diaphragm is activating at the second stage with the age of concrete is 14 days, and the loading is it's a cross barrier load we apply over there. And then stage 3 for calculation of long-term loss, we are giving it long duration. That's a 10,000 days I'm giving over there. So we have defined 3 construction stages. These are the duration of the construction stages. First stage is 20 days, second stage is 20 days, third stage is 10,000 days. And now one more thing we have to do, that is the construction stage for composite section. This is the second option, composite section construction stages. Here we have to define the 2 parts of the composite section, how we are splitting in based on the construction stages. This is my support section. Part 1 is the girder, part 2 is the slab. So second, I am differentiating by material. Okay, second is a slab property, and the composite stage. The slab is activating in the second stage. Age of concrete is 14 days. This also 14 days. And apply. Next, for the midsection, again for the material wise, it's differentiating by material. That is a slab material, and activating stage is stage 2, the age of 14 days. 14 days. Apply. Next is a composite tapered section. Material wise, set the slab and diaphragm, activating at the second stage. Age of concrete is 14 days. This is 0.38 and 0.18. Apply, and taper right is again differentiating by material. At the second stage, material is slab and diaphragm, and the age of concrete is 14 days. For both, height is a 0.38 and 0.18. And click OK. So 3 properties for the construction stage for composite section, we have defined it. Fine. Now we can do the analysis part. Go to analysis, perform analysis. So it analyzed completely. Now we can go to see the result, reactions, reaction force and moments, values and legend. Click apply. This is the reaction forces, and the red one is the maximum of all the reaction forces. For all the load cases, you can see the result. And then deformation. Check the deformation for self-weight and other load cases. And this is for the cross barrier load. And this is your deformation contour. And forces, this is the beam diagram. My is the bending moment. This is bending moment shape. Fz is the shear force. Mz is the torsion. And then stresses, beam stresses. This is the combined stresses for self-weight. And the 1 is the top stress, and 3 and 4 is the bottom stress. You can check the stresses for other load cases also at any locations. And you can extract this result in the form of tables. Select the load cases. This is a table value. And then you can take the output, there's a text output which is located over here. Text output, add new load set, select all the load cases, click OK, next, select the beam element, next, select the displacement and the reaction forces, and finish. So this is the standard output file from Midas. It will show the result for all the nodes and elements for all the load cases. including moving load cases. It takes a few seconds to generate the report. Yeah, it's created now. This is the output file. So this is the output file. And the input file is, go to the file, export, Midas civil MCT file, save the file in the local location, and this is your complete input file. Is the editor file. If you know the program sequences, you can just edit it, and you can just import this text file. The model will be generated automatically. Fine. So this is the modeling and analysis of a composite bridge, PSC type. Yeah, and I will show the other results like tendon losses. Now this is the tendon losses. It's calculating by the program for the cable number T1. This is stage 1. So this is the stage 1 for the T1 cable. Similarly, the last second stage, apply, it's keep on varying it. And this column is the residual force is remaining in the cable. This is the force remaining after friction and slip. This is elastic deformation loss. This is the creep and shrinkage loss and relocation loss. And for the same cable, what is the loss at the next stage? You can change only the stage level and click apply. Your result will be keep on varying it. Similarly, you can check the cable at any cable name, any change, any stage name. Click apply, it will be creating it. So this is the prestressed loss calculation. This result you can just directly export to Excel sheet. It's completed. Now you can open your local drive and then it will show the result. I saved it here. This is the tendon loss. Now you can see this is the tendon loss table which you exported from the software. I'm saving the cable coordinates also. So this is the modeling and analysis of the PSC composite bridge and analysis. And next session I will conduct for the design and the report. So we will do the member design for the composite design and the diaphragm design in the next session. This completely for the design purpose. Okay, and if you have any questions, you can just type it in the question box. You can type it in the question box if you have any doubts, please. And This webinar is a recorded one. I will send the link for your references. Fine. So thanks for attending the webinar. If you have any queries related to modeling and analysis, you can send to us. We will discuss in the second session also. Fine, sir. Yeah. Thank you very much. See you again in the next session for the design.